Okay, we retain another integral. This one's from the UNSW Integration Bee 2020. This is runner-up problem number 2. We have the integral from 1 to 3 of 3 to the square root of 4x minus 3 dx. Okay, to get started with this, I think it's really all about this exponent here. Now, if we could just reduce this, if this is just 3 to the x, that's pretty easy. We have this formula that we have this formula that we can use a lot where if we have an integral like something like a to the x, where a is a constant value, what we do is we can rewrite a as e ln a, and then now this is easy to integrate. And when we do that, a natural log a is just going to pop out in the denominator, and we're going to have this ex ln a repeat, but we do it in reverse, and we get back the a to the x. And so this is how we get this formula for an integral in this form right here. But in order for us to be able to use this formula down here, we're going to need to be able to reduce this somehow so we don't have a square root in the exponent. So what I'll do is, let's try a u substitution on this for the whole thing. So we'll write u as equal to the square root of 4x minus 3. And then I just want to solve for x, so let's square both sides. So we'll have u squared equal to this stuff. But let me just add a 3 on both sides to get rid of that. So then we have a u squared plus 3 over here. Divide by 4 to get rid of this, and we've got our value for x. But now let's just rewrite that as, we'll split it up and write it as u squared over 4 plus 3 over 4, because now I'm going to want to take a derivative of this to get a dx value. So when we do that, we have dx, power rule here, we get 2 over 4, or 1/2 u. This is just 0, and then we have a du. Now we'll go ahead and substitute over here. First, plugging a 3 in here. 3 times 4, 12 minus 3, square root of 9 is just 3. Plugging a 1 in here, we get back a square root of 1, which is just 1. This here again is u, so we're going to have 3 to the u. And our dx value is a 1/2 u du. Let's take the half out front of the integral, and we'll bring a u du over here. But now for this here, we can just use integration by parts on this. Let's use the di method or tabular integration over here to the right. Okay, setting up our di table over here, what we're going to do is we're going to differentiate u, and we're going to integrate 3 to the u, because we've got our formula for that. Now first, differentiating u, that's just going to give me 1 here. Do it one more time, we get back a 0. Integral 3 to the u, using this right here, is going to give me 3 to the u over ln 3. Integrating one more time, you could pull out a 1 over ln 3 as a constant out front and just use the same formula. When you do that, you're going to have 3 to the u over natural log 3 all squared. And now since we've got the 0 in the last row, we don't have to worry about integrating here. We're just going to take our solution on the diagonals. Normally I'd factor something out, but because we're going to have to evaluate it, I think I'll just leave it the way it is. So what's going to happen, let's just write it out. So the first one, we're going to have u 3 to the u over ln 3. And then for the second part, we're going to have a minus 3 to the u over ln 3 all squared. And we just need to evaluate from 1 to 3. So let's start plugging stuff in. So for this first term, we're going to have 3 times 3 to the 3. That's going to be 27 here. This is going to be over natural log 3. Then here, 3 to the 3 again, 27, natural log 3 all squared. And then for the second part, I think I'll just distribute in this 1/2 again. Plugging in 1, we're going to have 1 times 3 to the 1, or just 3 over ln 3. Then for the second part, again, we get a 3 over ln 3 all squared. And then to simplify, let me see if I can put together the terms that are in common, because we've got these, I want to put together these 2 that have an ln 3, and then pair these ln 3 squared terms. So we'll bring 1/2 in front here. 3 times 27, that's 81. Minus 3 is going to give me 78 over ln 3 here. So then putting these together, we're going to have minus times minus plus 3 minus 27. So I'm going to have a minus 24 over natural log 3 all squared. Cancel 2 with 78 and we get a 39 here. Cancel 2 with 24 and we get a 12 here. So for my final solution to this, we have 39 over natural log 3 minus 12 over natural log 3 all squared, and that's it. Okay, there you have it. Good one from UNSW 2020. Thanks everyone for watching. Have a good day.